and in algebra. So sometimes that will mean assigning a variable. Sometimes it will mean assigning an expression. So sometimes we say like one piece of rope is 6 feet longer than another piece of rope. So we could call the shorter one X and the longer one X plus 6, right? Because it's 6 feet longer. So sometimes we will assign a single variable to one of our unknowns. Sometimes we'll assign a expression. At this point, I've made this as general as possible so we can apply it to systems of equations later on, which have more than one variable. But at this point, we're just working in one variable today. So we'll just assign one variable to one of our unknowns, and then if necessary, we'll assign expressions to the rest. When we translate the problem into an equation, the only thing that really is worth mentioning in this step is that you can't, so the number of equations that you have to write corresponds to the number of variables that you use. If you use one variable in the first step, if you assign one variable in the first step, then you write one equation in the second step. If you have like 3 unknowns and you call them X, Y, and Z, then you better be able to come up with 3 equations. Otherwise, you're not going to be able to solve for any of the unknowns. So that's one of the reasons that we assign expressions to some of our unknowns instead of variables, so we don't end up with like a single equation with 3 variables in it and like no way to solve. You also may have to look for formulas, and you're welcome to use the internet to find formulas that you don't know, like for the perimeter or area or volume or the relationship between angles in a triangle or a square. That's totally fair game. I won't give you anything on a test that we haven't like at least gone over in class. I mean, if I think about what's been on tests, like I think it's pretty much limited to like the volume of like a box and like the area of a rectangle. But anything else that comes up on homework, you're welcome to use the internet to look up any formulas that you don't know. So then we'll, of course, solve the equation or system. It turns out this ends up being the simplest part of these problems. Once you actually write the equations themselves end up being fairly simple. So you solve for x. Every time I solve for x, I ask myself, what did I just find? And I go back up to step 1, and I look at what x represented. Because what we're finding isn't always necessarily what the question is asking for. And as we get more and more unknowns going on in a problem, it's going to be more and more important that we kind of look back frequently to like remind ourselves what we actually found, because it's easy to get things mixed up. And then the last thing is to answer the question with a sentence. Notice it says no math symbols. You want to like answer as if somebody asked out loud. So answer with a sentence you would actually say, out loud. So if I ask you how old you are, I don't think any of you would say x equals 18, right? Like nobody talks that way. So if you're writing a sentence, it wouldn't make sense for your sentence to be x equals 18 either. So you want to, like, in this last step, so what we're starting with an application problem that has no math in it. And then this last step, you should be ending with a sentence that has no math in it. The algebra is what we use to get from point A to point B. But then you want to actually come back to the real world and be like, I am 18 years old, not x equals 18. Good stuff? Okay. So the width of a standard tennis court used for playing doubles is 42 feet less than the length. The perimeter of the court is 228 feet. Find the dimensions of the court. So let's start with what dimensions mean. What does it mean when I say what are the dimensions of a rectangle? Yeah, dimensions are length and width, right? And you don't have to be super specific. Like once you find them, you don't have to be the length is and the width is, because in reality, they're really interchangeable, right? Like nobody knows which way the tennis court is facing. When you look at a piece of paper, you're like, this is an 8 by 11.5 inch piece of paper. You're not like, the width of this paper is 8 inches, right? So it's not, in the sentence part, it's not that you have to write more or you have to be super specific. It's just that you have to be realistic and like, you know, in terms of the real world. So dimensions just means find length and width. I can can write this morning. And so when I look at this problem, I see that my two unknowns are in fact length and width. So I'm just going to list them. So length equals something, width equals something. So I'm only allowed to have one variable. Which one should I assign x to? It doesn't really matter. There's maybe a more convenient choice, but I mean, as long as you're consistent, you're right, it doesn't matter. You can just pick one and then use the information in the problem to write something for the other one. But I would say in this case, it makes the most sense to assign the variable to the length, because they say the width is 42 feet less than the length. So like they tell you how to find the width if you know the length. So if we make the length x, then they tell us take 42 away from that number and you'll find the width. So the width would be x minus 42. And realistically, if you can deduce that that means that the length is 42 more than the width, you could make the width x and make the length x plus 42. This way just doesn't require any rearranging of that relationship. And so then we have to think about what our equation is going to represent. So the simplest way to figure out how to write your equation, I think, is to look at what they give you. So in this case, they give us the perimeter. So that's what they give us an actual number for. And then ask yourself, okay, if I knew the width and length, how would I find the perimeter? So how do you find the perimeter of a rectangle?
You add all the sides?
Yeah, you just add all four sides, right? We can draw a little picture. This is x. This is x minus 42. So the perimeter would be x plus x minus 42 plus x minus 42. And then that's going to be equal to what they gave you. So the idea is taking something that they gave you a set number for and writing an expression for it using the variables in step one, and then you can set them equal to each other. There's also a formula for perimeter. It's 2 times the width plus 2 times the length. You could use that as well. Although I always thought it was kind of a silly formula to memorize when you could just add all the sides up. It just seemed like more brain power than necessary to memorize something that we could do just by adding everything up. But either way is fine, and when you simplify the left side of either of those equations, you end up with 4x minus 84 equals 228. And so we will then solve that equation. We'll start by adding 84 to both sides. So we have 4x equals, that's a 2, that's a 1. Somebody should check that. That's totally wrong. Holy.
3 should be.
Thank you. It's early. I feel like I understand test anxiety sometimes when I sit up here and like try to do like a simple calculation in my head and I like freeze up. I'm like, I don't know what 8 plus 4 is, because I feel like on the spot. So definitely always check if I know what I'm talking about. So this is 78. Yes. What did I just find? We just found the length, right? So this is my length. I also need my width. So it's always a good idea here at this point, like right before that last step, to go back and read the actual question again and figure out what it is you're actually trying to find. So again, we want the dimensions, so we want the length and width. So we just found the length. The width is going to be our length minus 42, which is 36. And so the court is 36 by 78 feet. I feel like that sounds weird. It should be like 78 by 36. But nonetheless. Questions? So I didn't number like the 4 steps. If you want me to, I can. You don't have to number the 4 steps. I will just look for all of them. Like on tests, I usually make problems like this worth 4 points, and it's literally like 1, 2, 3, 4. So I'll look for all 4 steps, but you definitely don't have to number them. But if it helps to see where each one fits in. Yes?
1 feet, how many meters, more or less, you know?
1 foot is about 1/3 of a meter. So a meter is like, I believe, a little bit more than a yard, which is 3 feet. I don't know which one's a little more, a little bit less, but like a meter stick and a yard stick are about the same length. So a foot is like 1/3 of a meter. It's like 30 centimeters-ish. Our system of measurement makes absolutely no sense whatsoever. Okay, so the sum of 2 consecutive integers is 97. We want to know what those integers are. So in these problems, when we have like 2 unknowns, we typically get 2 pieces of information. So one piece of information tells us how the numbers relate to each other. So back here, that was the fact that the width was 42 feet less than the length, was how the 2 unknowns related to one another. And notice that that comes up right here. So that piece of information only really shows up in that step. And then we are given information about how those numbers relate to some other number. In this case, it was how they related to the perimeter. And that's what allowed us to write our equation. So the same thing is true here. We're given one piece of information that tells us how the numbers relate to each other. And then we are also told how they relate to the number 97. So what piece of information tells us how they relate to each other? So that's how they relate to the number 97. Right? So that tells us how to get 97, but there's one other piece of information that's kind of hidden in there. That they're consecutive, right? Which means they're one after the other. So if the first number is x, then the second number, is going to be x plus 1. Very good. So just one more than the first number. And so we use this piece of information there in that setup, and we didn't use anything about the number 97 or anything else. So whenever you have these consecutive integer problems, that first step is always going to be based only on the fact that they're consecutive. So x plus 1, or if they're consecutive odd or even numbers, they differ by 2, right? You skip 1 in between all odd numbers or skip 1 in between all even numbers. So that first step should only have to do with that piece. And then the second step, you'll say, okay, if I add the first number to the second number, I'm going to get 97. And so once we get that far, this equation's not too awful to solve. 2x equals 96, and x equals 48. So I found the first number, which means the 2 numbers are 48 and 49. Like, you don't even have to write the 2 numbers are. You can just write the 2 numbers. Those are my 2 favorite numbers. So far, so good? Okay, you guys try this one. So there's 3 numbers this time, and notice that they are consecutive odd numbers. So think about how those are going to differ from one another. Odd, like 3 and 5 and 7. Be sure you list your unknowns in words as well as in algebra. Be sure you do that first step where you list the words. Okay. Like this says that X is 1. See what I mean? Yeah. Even though you know what you mean, just so you can write like first, just to make it not look like a number. There you go. And that way when you solve, you're actually getting the numbers. So even though like it seems strange because they're all numbers actually equal to about 2, just like even numbers do, because you skip 1 in between. So even though it feels like we should be adding an odd number, we're actually just doing 2 equals to 2. Perfect. Yeah, so they differ by 2 different numbers. So you would skip 2 in between. Nope. Yeah, there you go. Right, because like 3 plus 2 is 5 plus 2. Perfect. 17. No, that's perfect. 17. It goes in the first one. Yep, perfect. Excellent. Yeah, you got it. Very good. Perfect. So just 2 more than this. Yep. Very good. We get that 51, huh? And it's like, it's one of those weird numbers that we don't really know is divisible by anything. But it turns out that it is 17 times 3. So when you divide it by 3, you just get 17. You guys know the trick for how to figure out if a number is divisible by 3? What is it? Yeah, if you add all the digits of the number and that's divisible by 3, then the number is. So like 51, 5 plus 1 is 6. So we know that we can divide it by 3. And remember, it's okay to use your calculator. If any of you are returning students and you're coming from like 065 or 096, like where we didn't use calculators, I know it's like a new habit to get into, to like pull out your calculator, but it's totally okay to use it. Yes?
Isn't there a trick with 9s too?
Yeah, 9 is actually the same exact trick. So if you add all the digits of a number and it's divisible by 9, then the number itself is also divisible by 9. And that's really just because 9 is 3 times 3. So it's really just doing the trick for 3 twice, because that gives you 9. There's also a rule for 4s and for 11 and 2, well, if it's even. And there's even one for 7, but it turns out that the trick for 7 is like more complex than just like trying to divide by 7. And so we typically don't use it. I don't even remember what it was. I learned it a long time ago. So we said that there are 3 numbers, the first number, the second number, and the third number. And I'm totally fine if you abbreviate here. It's not so much that I care like how much you write. as I do, that it's really clear that, first of all, that none of those are a number. So you don't want to do like 1, 2, 3. So you don't want to, because that would mean that x was equal to the number 1, right? Even though like you know what you mean. You just want to be really clear. Again, we're setting up for later when we have more unknowns and more things going on. And you want to be specific enough that, again, you know what you're talking about. So like if we have a problem where we're talking about like out-of-state students and in-state students and freshmen and sophomores, and you say x equals students, then it's not super clear which students you're talking about, right? So it's not so much that like I'm looking for you to write a whole bunch when you write things in words. I just want to make sure that you're specific enough that it's clear to both you and your reader exactly what you're talking about in terms of the problem. So we said x, and then I think everybody had this, so I'll do it really quick. Then x plus 4. So then when we add all those together, we get 57. And that gives us 3x equals 50, plus 6 equals 57. And the solution to that is x equals 17, yeah? Anybody want me to go through that slower? Okay. So 17, 19, and 21. Good? Beautiful. Okay, so now we're going to write, so the next two problems, we're going to write a model and then we're going to use a model. In this situation, we're told that our cell phone plan costs $40 per month, which includes 3 gigabytes of data. I'm an old lady, so if this is totally unrealistic, like, I'm sorry. Like, I don't know. If anybody uses 3 gigs anymore, that might be, like, unheard of. Or does anybody pay by the gig anymore? That's true. Okay. Maybe I'll update this. Back in my day, we like paid by the minute, you know? So, okay. So $40 per month, it includes 3 gigs, and then any data beyond that is charged $10 per gigabyte. So if you use 9 gigabytes in August, we want to know what the total bill will be. So this is one of the tools for writing models that is really, really useful, is like this calculation, I think we could all do really, really quickly. But if you slow down and really think about and write out exactly how you started with the number 9 and ended up with the total cost, you can use that to generalize the model. So starting with a specific calculation that is somewhat simple, if we can be really deliberate about writing that calculation out, then all we have to do is replace the 9 with an x, and then all of a sudden we have a model for x gigabytes. So tell me how you would calculate the total cost. Yes?
Well, our constant would have to be 40.
Yes, 40 would be a constant. And we'd add that to
10x, assuming that x represents the amount of gigabytes over 3 gigabytes.
Okay, good. So in this case, what would x be?
Like I said, the amount of gigabytes over 3 gigabytes.
So if we use 9 gigabytes,
That would be 6.
it would be 6. And how can we get the 6 from the 9? Subtract, right? So if we did 9 minus 6, perfect. So what is that, 70?
Yes, 3.
I'm sorry, thank you. Which is then 100. There we go. And so now we want a model that represents the total monthly cost. And remind me of your name again. Sean brought up a great point, which is, so he said that x could be the total number, or the number of gigabytes over 3 that's used. And that's one way to do this. If we were to do that, we would say the cost is equal to that constant 40 plus 10 times what? X. And we didn't have to subtract that 3 because the way we defined x was that we already used the 3 gigabytes. And so x is just whatever we use beyond that. So if you said x is equal to the total number of gigabytes, then our cost would be 40 plus what? So we'd still have to multiply that 10. And yeah, and then, but then we'd have to take the 3 that we already paid for away from the total number before multiplying it by the 10, right? So x minus 3. So these are actually the same equation. This right here that we're multiplying by the 10, in both of these cases, is the number that we went over, like the amount of gigabytes that we went over the 3. We're just expressing it in a different way. And neither of those is wrong. Like, those are both perfectly correct. However, if you say this and write this, that is not accurate, right? So a lot of this just comes down to, like, how you set the problem up and then just being consistent. There's a similar problem to this on tonight's homework having to do with carpet. So be really careful that you're conscious of if you're saying x is the additional or if x is the total, and then your equation needs to reflect that. Like I said, neither of them is wrong. Sometimes these problems will tell you what x represents, in which case your equation should correspond to that. Does that make sense? So if your bill in March is $120, we want to know how much data we use that month. So I'm going to use, I don't know, you guys want to use the one on the left or the one on the right? The one on the right? Okay. So we're going to use this one, just so we're all agreed what we're using. What we're given here is C. We're told that C is equal to 120. So we're given, in a sense, the output of this equation, and we're trying to solve for x. So we're going to say, we're just going to replace the C with x, just like yesterday when we were evaluating. We're essentially evaluating here, but we're given C instead of given x. So we have 120 equals 40 plus 10 times x minus 3. So we're going to simplify on the left first. So 120 equals 10 plus 10x. And so x equals 11. And because we use the equation on the right, we found our final answer. That's the total number of gigs. That includes the 3 because we built that extra 3 into our equation. If we had used the other equation, when we solved, we would have gotten 8. And then we would have had to add that 3 back on and said because it's 8 over the 3, so the total number used was 3, or 11. So 11 gigabytes were used. So, I mean, I think some people think this is a positive and some people think it's a negative, but we're sort of moving beyond that, like, kind of math where, like, there's, like, one right answer. A lot of it just has to do with what exactly you're trying to do and how you set it up. So, like, there could be many ways to set these problems up correctly as long as you're consistent and clear, and that's why we label everything at the beginning, is because you're setting things up for yourself and telling the reader what everything's going to represent so that what you write makes sense, right? So, like, if I didn't have this statement or this statement, well, then which one of those is the right equation, right? Like, it doesn't make sense without knowing what our x represents. So, I don't know, some people want it to be super cut and dry, but it's not always totally cut and dry. Sometimes it just depends on the context and kind of how you decide to start. But that's a good thing, too. There's freedom for creativity. Okay, last one. So in this problem, they give us our model. It's right here. That means that we don't have to say what x represents and what y represents because the problem told us. However, I will note that When these problems get more complicated than this and there's more than 2 unknowns, it's actually worth still making a list because it kind of gives you like a key to look back on so that you don't have to read through like this huge paragraph every time you're trying to figure out like what X was or what Y was. So like I'll often just be like Y equals, so the equation can be used to estimate the monthly premium. If it says the equation can be used to find such and such, then the variable that's alone is the one that represents that. So in this case, Y is the monthly premium. So Y equals the monthly premium. And then X equals, here it says X is the number of years over 40. So X isn't the age. Like if I gave you X equals 1, that would not mean that the issue age was 1 year old. It would mean it was 41 years old. So it's the number of years beyond 40. So age after 40. Or years after 40. You can write that however makes sense to you. We often do this in math where we like pick a realistic starting point. So remember I told you earlier, like the model that we use for like population growth now is not the same one we used back in like 1940. So if I wrote a model for population growth right now, it wouldn't really make sense for X equals 0 to represent like the year 0 AD, right? Because the model is not going back that far. So we'll often be like, X equals 0 corresponds to the year like 2010. And then that way we don't have to plug huge numbers like 2019 into our equation just to like have 2,000 years for which the model didn't even make any sense. So we kind of like set a starting point where it's realistic so that we can work with easier numbers. So I want to estimate the monthly insurance premium for a female who is 48 years old. In these problems, when you've got a model with 2 unknowns, if they give you one, or if they ask you for one, they have to give you the other, right? So here we want to find, so we're finding Y, which means some piece of information has to give me X, which in this case is the age. This tells me that X is equal to 8 because it's 8 years past 40. So we have Y equals 2.8 times 8 plus 23.7. So this is really similar to the evaluating that we did yesterday, but notice that I wrote both sides of the equation. So these models or equations, they have a left side and a right side. So just like when you solve equations, you want to show both sides of the equation. So I don't want to see like any of that in your homework. Like make sure that you have both sides of your model all the way down. So even though we don't really have to do anything with that left side. So we have Y equals, somebody want to punch that in their calculator? What is it? 46.1, thank you. So the monthly premium is 46, I might write 4610 just because that's how we usually talk about money. If you wrote 46.1, that's fine too. Make sure you put units on there. So we want to put that $sign on there. And then the second piece asks what it asks for our issue age. So that means we are finding X, which means that they must have given me Y or given me some piece of information that would tell me Y. In this case, they just straight up gave it to us. Y equals 99. So again, we're going to write both sides of the equation. In this case, we know the left side. So we're going to replace that Y with 99. And solve for X. Can somebody help me out with a calculator? 99 minus 23.7 is like 75.3, and then when I divide by 2.8, I get 26 point, I'm just going to call it 26.9. So what is this person's age approximately?
26.
So like 67-ish, right? Remember that X is the number of years beyond 40. So, I mean, you could say 46.9. I would probably say around 47 years old just because, I mean, I don't usually say I'm like 41.3 years old. But I probably wouldn't scream if you said 46.9. So about 60, what is it, 67 years old. Oh, that worked out perfectly. Here's your homework. You have no online homework tonight, so it's just the written homework that is listed in that written homework column of your homework sheet. There's 5 problems. Remember, you can find the textbook in my math lab and just type that page number in. Have a great day.